Good afternoon, students. Good afternoon, teacher.
Good afternoon, teacher.
Students, today our subject is computer.
Chapter number 1, Memory and Storage Devices. The one who remembers a lot of things is said to have a good memory. Do you know that a computer also has a memory? Yes, it has. A computer works according to the instruction given to it. It follows the input process output cycle or IPO cycle. Once you give the input in the form of data and instruction to a computer, it starts working on the input with the help of a processing device and finally gives you the desired output. CPU is the brain of the computer, controls all the data and instruction given to it through input device and stores it in its memory. This data can be retrieved from the computer's memory as and when required during the processing. Computer memory. A computer has two types of memory, that is primary memory and secondary memory. The primary memory helps in the flow of information and performing calculations. The secondary memory is required to store input and output data permanently. Primary memory. The primary memory is located inside the CPU. The control unit can quickly access and easily read the program and instruction contained in it. The primary memory is also known as the main memory of the computer. Motherboard. Characteristics of primary memory. Some of the characteristics of primary memory are: it is very fast. It is located on the motherboard. It cannot store large amount of data. It stores data and instruction associated with the current process being worked upon by the CPU. Primary memory is of two types, RAM and ROM. RAM stands for Random Access Memory. It is attached to the slots of the motherboard. When you switch on a computer, the software gets loaded temporarily onto the RAM from the hard disks. Whatever work you do on a computer is done on RAM. Therefore, RAM is also called the working memory of a computer. It is also referred to as the read and write memory, as you can easily read or write data on RAM. The data you use while working on a computer gets stored temporarily in the RAM. When you switch off the computer, all the unsaved data gets lost. So, it is important to save data before switching off your computer. Thus, RAM is volatile or temporary memory as it loses data in the absence of power supply. The ROM stands for read-only memory. It is located on the motherboard. The data and instructions written in ROM are essential for a computer to boot. You cannot change these instructions as they are permanent in nature. So, ROM is called non-volatile or permanent memory of a computer. It does not lose any information when there is no power supply or when the computer is turned off. Not all ROMs are read-only. Some ROMs allow data to be written on it by users. For example, PROM, Programmable ROM, EPROM, Electrical Programmable ROM, EEPROM, Electrical Erasable Programmable ROM. secondary memory. You know that RAM is volatile memory and you cannot store data on ROM as it is read-only memory. To store data permanently, you can use secondary memory. It has ample space to store large amount of data. Secondary memory is also known as external or auxiliary memory. The devices that you use to save data are called data storage devices or storage devices. These include SD card, HDD, pen drive, CD. Advantages of secondary memory. Some advantages of secondary memory are it can store large amounts of data as compared to the primary memory. It is permanent in nature. Once you save your data and instructions in the secondary memory, they will not get deleted until someone deletes them manually. You can easily change or delete the data stored in most storage devices. You can easily transfer data stored on secondary devices from one computer to another. Storing data in computer memory. Computers have a large amount of storage capacity to store information. The smallest unit of measurement of data is called bit. A computer stores data in the form of bits. 8 bits combined to form a byte. The large amount of data stored in computer is measured in larger units such as kilobyte, KB, megabyte, MB and so on. Table 1.1 shows some larger units of measurement of data. 8 bits is equal to 1 byte. 1024 bytes is equal to 1 kilobyte KB. 1024 kilobytes is equal to 1 megabyte MB. 1024 megabytes is equal to 1 gigabyte GB. 1024 gigabytes is equal to 1 terabyte TB. 1024 terabytes is equal to 1 petabyte PB.
Thank you, students. Thank you, teacher.
Thank you, teacher.